Hey there, and welcome back to another episode of the Ruby Rogues podcast. This week on our panel, we have Valentino Stoll.
Hey now.
I'm Charles Max Wood from Top End Devs, and this week we have a special guest. It's Jean Boussier. John, do you want to introduce yourself? Let us know who you are and why you're famous.
Hey there. Yeah, famous, I don't know, but I've been working at Shopify for 9 years now.
Oh, wow.
And yeah, I know. And I ended up being I'm now a Rails core contributor. I'm also like a Ruby committer and maintain a bunch of gems there and there. And over my time at Shopify, I worked on many different things, like a lot of CI and continuous delivery, many kind of like SRE kind of work. And now I'm on the Ruby and Rails infrastructure team, so I work like quasi full-time on either open source or like upgrading or open source projects inside Shopify.
Very cool. So we brought you on to talk about Pitchfork. Now, Pitchfork, it looks like it's a rack HTTP server. I think the ones that I've used that kind of compare are Unicorn and Puma. But do you want to kind of give us the 10,000 foot view on what Pitchfork is and why people might want to think about it?
We definitely need to dive in to explain how it works, but basically,
right.
It started as a fork of Unicorn. So in terms of ergonomics, it's going to be very much like Unicorn, but it's going to use way less memory than Unicorn because it uses this semi-new technique, which is reforking, to improve the copy and write performance of your application. We're definitely going to have to explain that a bit later, but basically, it's better at sharing memory.
All right. So, yeah. So it's an HTTP server. You're probably going to have less, memory usage. So do I, just to get started with using it, do I just, pick it up and use it just like Unicorn or Puma? Or do I have to do anything else to get it to go?
So hopefully in a bit, yes. But right now, there's a few challenge. Right now, it's very much like I think I'm clear in the README. It's experimental. I'm currently working on onboarding one of our apps in production to iron out any kind of issues we might have. But it's always going to be slightly harder than Puma and Unicorn to onboarding. Because what it does is that to improve the memory usage, it periodically refork your application. So if you're familiar with Puma and Unicorn, they boot your application and then they fork once, or they fork multiple workers from the same process, and then they stop there. What Pitchfork does is that frequently, on a regular basis, it's gonna tell one of the worker, okay, you're the new master process now. And it's gonna switch. Yeah, it's gonna become the new master, and the old worker is gonna one by one shut down, and the new master is gonna create new ones. So that's all it achieved, a much better copy and write performance, because as your process lives, when you start forking, you get an exact copy of the memory of your parent. But it's thanks to copy and write, you don't have a physical copy. It's just you're pointing to the same memory region. And then whenever you touch, you write into one of those memory pages, the kernel just stops you and make a real copy and gives you a real copy. So which means when you fork a process, 1 gigabyte process, and you end up with 2 gigabytes, 1 gigabyte process. And if you look at the RSS, the memory usage, the kernel, you're going to say, oh, yeah, it's using 2 gigabytes. But in truth, it's using just 1 because everything is shared.
Right.
And so that's all Puma and Unicorn don't use too much memory. The problem is that Ruby is not particularly well, it's not that it's badly designed, but it's not trying to optimize for this so much. So, for example, when you compile your file, there's inside the VM, you have some bytecode, right? And to improve performance inside this bytecode, Ruby reserves some teeny memory regions where it caches things. For example, if you look up a constant, it's going to say like when you compile your method for that constant, it's going to reserve like a teeny, like 2-3 bytes. And the first time you execute your method, it say, oh, I don't know what that constant is. And it's going to do a slow constant lookup. Like it's fairly heavy operation. But then it stores that in that teeny cache, what's called an inline cache. And on the next execution, it's going to say, oh, I already know what that constant is. And so the problem with that is that with Unicorn or Puma, you boot your application, but you never execute most of the code, right? Let's say your controller, you're not going to call your controller during your boot phase. It's only after you forked that you're going to execute it. And so you fork, you share 100% of your memory, and then just after a few requests, you're going to let just 30 pages after pages, and then you're only going to share like half of it, basically. From what I measured in production, most applications after just 100 requests, they fall to like 60 or 40% shared memory only.
So effectively what you're talking about, and we've covered processes and copy on write and stuff in previous episodes. It's been quite a long time since we've talked about it. But yeah, effectively you fork the process and it says, well, I'm just going to, rather than, copy everything that I need from the old process, I'm going to use the same memory space as the old process. And then when I have to overwrite something that was in the old memory space, that's when I add that specifically to my memory, because I don't want to pollute the other memory space. And so what that does is it allows your processes to run without a ton of memory bloat on stuff that everything that's forked off of that one process already knows about.
Yeah, that's an excellent explanation. Because in a running web server, it's going to depend from an application to another, but you're going to have a huge part of the memory that is going to be the same in every process. You're going to have the memory you use to like render your request and things like that. And you're going to have like all the supporting memory where that's all like your code, your classes, your translation data, all these things. And that's so Pitchfork achieved like much better memory performance, is that it just is able to share much more. The downside is since you refork, that's why like fork is not very popular in many circles, is that when you fork, two bad things happen. First, all the threads but the one you forked from end up dead in the child. So if you have like a background thread that was like keeping things updated or whatever, you need to make sure to restart it in your children.
Okay.
So that's a first challenge. So like if you have some libraries do this, they start a thread to do things and then you fork and the thread is dead and it no longer works. A famous library that does this is gRPC, and they do this in like CLand. And historically, if the thread was dead, like your main thread would wait for something that the background thread was supposed to do and that would never do, and the process would just lock forever. Right? So very bad things can happen if you have some dead threads. And the second thing that many application or lots of code doesn't deal necessarily very well with is that you inherit all your file descriptors. So that's the term, but file descriptors are everything that's like open file, open sockets. So if you have something like, say, a database connection or like a Redis connection, and you fork, both the children and the parents are effectively in the same connection. So for instance, the parent does a query and the children does one as well, they might get each other's response. So you can have terrible things where, so very often like
what's wrong with that?
Yeah, I guess it's just like you're just playing Russian roulette with your network packets, basically. So this can, like, people who have done like Ruby deployment for a while, either with Unicorn or Puma, they're somewhat familiar with this because they know that, for instance, Active Record or something, you need to configure Puma to close connection and before fork and reestablish after. So they know about this, but the thing is, like, the vast majority of the code is not executed during the boot phase, and Puma just boot your application and then fork. So there's lots of code out there that wouldn't support being forked after they have been being used, but that currently works with Puma, but wouldn't work with Pitchfork.
Mm.
So that's why, like, I put a big warning on Pitchfork. Is like you need to really own your stack, being able to vet your dependencies to know it's gonna work with, or either that, or you need like a very good staging on which you run tests to figure out the problems. Like, don't go willy nilly enabling it in production because you're gonna have trouble. That's for sure. My hope, though, is that in the near future, it's going to be a bit easier because historically, I don't know if you remember like the Rails 3 days where you had to say, oh, like you had like the thread safe mode for Rails because nobody was running thread at the time. And in the end, it didn't took that long for the community to just make most of the code out there thread safe. And so I'm working on like popular gems and things like that to make them fork safe, like refork safe. So for instance, I made patches for the connection pool gem to automatically detect when the process was forked and just abandon all the connection and start over. Like just today, I was making a PR to a HTTP gem that's called a XCon or something. Like I'm just looking at like the popular gem that may have trouble with this, and I'm just like submitting patches so that like the ecosystem just becomes more compatible with Pitchfork. And I'm just generally working on improving the ecosystem around this, so that hopefully in I don't know a year, 2 year, enabling Pitchfork just become like just adding a gem to your gem file and you're good to go.
Makes sense. So I kind of want to step in and just see if I understand what Pitchfork is doing then. So what you said was that Puma effectively stands up the app and then forks immediately. And so everything that forks off of that master process they only share whatever's initialized on the app. And so what you're saying is with Pitchfork, when you fork off of something that's been running for a while, it's going to share more memory because it's loaded in the stuff that it needed when it shared or when it ran. And so it'll share a larger percent of the memory.
So that is true. That is one of the things because like there's this pattern that is very common in the Ruby community, you know, which is like the Oracle, like lazy memorization kind of thing. And so it's not uncommon to see application that grow in memory after they're being deployed and then they stabilize, right? So there's definitely this dimension, and Pitchfork's gonna help with that because after a few requests, all this like when your memory stabilizes, it reforks from that, and so that's gonna help. But in addition, there's the thing I talked about a bit earlier, which is like say like the inline caches in the virtual machine, is that there's memory region, especially that when you just booted your application are not yet initialized. And then once you execute that code path once, it's stable, like it writes into it. So it invalidates copy and write, but it doesn't invalidate copy and write on every execution, only on the first few ones. So there's this idea of like, for the first few requests, your memory pages are very volatile, like it's going to be invalidated a lot. But as you go over like requests, more and more requests, as your application warms up, that's no longer will be the case. So the heuristic Pitchfork used right now to know when to do a new generation, like refork new workers, is like based on number of requests. And what I've experimented with for now is just like, oh, after 100 requests, you do a new generation. And then after 1,000 more requests, you do yet another generation. And the idea is that after a while, you don't even need to refork anymore. It's just stabilized, right? Because if you look at the copy and write efficiency graph, right? If you look at the memory metrics and you see how many pages are shared, you're going to start at 100% and you're going to drop very quickly to like something like 50-ish%. And then you're going to have like a very slow curve. Like it's going to be a logarithmic or asymptotic kind of curve with a very slow decrease. And once you're there, it's good. You can just forget about it. It's stable. So it's a bit like a JIT, you know, that need to warm up. It's kind of the same idea, but you need to warm up to share more memory.
That's really cool. So what made you want to write this?
Right. That's a very long story. So, as I said, I've been working at Shopify for like 9 years or something, and I've been working on Monolith a lot, which is I can't gigantic. Like really, you have no idea how big it is.
Uh-huh.
And so I've been focusing on like memory usage for a very long time. Like it's been, I think like 4 or 5 years. I'm just regularly, it's like a kind of a chore I come back to, I just look at like, where did we degrade? Where did we start using more memory lately? I have a set of dashboard. I have like, I've written something that's called heap profiler that take like heap dumps and just makes you like a kind of a summary of where your memory is being used. Like I've been doing a lot of work in that area for a while. And credits to with you. At some point, I saw like I found some kind of experimental feature in Puma that has been written by. I'm really sorry. He recognizing himself. Someone who write like an experimental feature for Puma, but kind of like pretty much does the same idea of like reforking. So they call it refork walker, I think, or fork walker. Which is the same idea than Pitchfork, but the way it's implemented at like a major limitation is so in Puma you have like the master or control process, like the cluster process that forks the workers, and what they did is that they said, when you trigger a refork, then the first worker become like forks new workers by itself. But then what you end up with is like you have the cluster, which is a parent of the worker 0, which is a parent of the new generation of worker.
Mm-hmm.
So now you not only have like a parent and some children, you have like a grandparent. And the problem with that is that if the middle process, the one that the worker 0 dies, your workers become orphans. And that's, like, that's sometimes you hear zombie process, not really the same thing, but like, it's like in Unix, when you want to do a daemon, like demonize a process, you fork twice, right? Mm-hmm. You do a middle process and then you let the middle process die. And the grandchildren is reattached to PID1, which is like the init process, and it becomes independent and nobody tracks it. And that for a web server is very bad because it means like you have no control over that child anymore and like you don't know what happened. And so I was like, whoa, this is like a cool idea, but there's no way I put that in production. Like we're gonna like, it's just too dangerous, right? And I was, I don't know, on Hacker News or something, and I saw something that was added to Linux just like 5 years ago or something, which is called Pierre Child Sub Reaper. And so it's a new API in Linux where you can, as a process, you can declare yourself as not exactly the new init, but you're going to say if any of my children or grandchildren or whatever become detached and need to be reattached to someone, reattach them to me. And that's where it hit me that it was actually possible not to fork children, but to fork siblings. So it was possible for a process to like fork siblings of itself if the parent was cooperative. And that's when I put one and one together that I was like, oh, we could do this cool thing. And that's when I started working on Pitchfork, because that was a combination of those two ideas. Oh, and I should say, this need for this feature means that like the main appeal of Pitchfork is Linux only. Like you cannot, like you can run Pitchfork on macOS or FreeBSD or whatever, but you won't be able to enable reforking unless you have this feature.
So I guess the other question I have is this something that you're using at Shopify now? And what kind of results are you getting out of it?
Right. So unfortunately, not quite yet. I'm actually working on it this week because I wrote Pitchfork last year towards the end of the year, and then there was a new Ruby release coming up, and I'm the guy, since I had experience in CI at Shopify, I'm the guy who would just run nightly builds to make sure the release is going to be nice and clean for everyone. So I just put Pitchfork on the side for a bit, and it's just like this week that some team said, oh, we had this problem, whatever, do you want to try Pitchfork on our app? And I was like, you know what, all my beer, I'm just I'm gonna come. So I'm like working on making their app fork safe right now, and hopefully I should deploy it like next week or something. So if you want to know, just follow me on Twitter or whatever. I will probably share graphs or numbers soon. But that's my hope. And so now, other than that, I only have like micro benchmarks. If you look at the Pitchfork repo, there's a specially crafted application to showcase what I've talked about before, like the inline caches and things. So it's something like an application that's about 300 megabytes, like one process. And I benchmark Puma 2 workers and 2 threads against Pitchfork 4 workers. And Pitchfork can end up using like twice as little memory as Puma. But again, it's I don't want to give too much hopes. All those results are extremely dependent on what your app is doing. Different applications going to have very different memory profiles and will be able to benefit much more from Pitchfork than others. So it's going to be very, very valuable.
So I never knew that you could eager load namespaces like that in Rails. Do you find yourself like, as Shopify, like throwing a ton of stuff in that eager load process? Or is that like a huge, or is that like a huge no? Like, hey, we're getting to our limit. Like, maybe we should back off.
No, actually. So yeah, that's funny because that's kind of a misconception I try to fight against. Is that there's many developers who they try to lazy initialize things because saying, oh, we might not need it, so might only compute it when we need it, and then we store it because it costs us a lot to compute. And the problem with that is if it's not initialized during boot, the first request to hit that code path is going to be slower than the remaining ones. So I'm going to talk about something that many people may have experienced, is like those shark fin looking latency graph when you deploy. If when you deploy your app, you see like latency raising, it's very likely that you have way too many lazily initialized things in your application. It's not a good thing. I'd much rather make the boot time a bit slower if it means that I have like much smoother deploys where latency stay stable. And so yes, you have this thing in Rails which is like eager load namespaces, which is very useful for these things where you can have something lazy in development and then you put it in that list and Rails will call it for you, like eager load it, like it's going to call a method on it that allow you to pre-warm those objects during boot. So that's going to ensure that it's booted in the parent. So if it's going to be that's going to be in a memory region that is going to be copy on write later on. So you actually might not pay as much because you think like, oh, I'm going to add like 1 megabyte to my process. But if you use, say, 10 children, you're not adding 1 megabyte, you're adding 100 kilobytes. And that's why like, that's another dimension of like how to reduce memory usage in production is to use bigger servers or bigger boxes. I hear a lot of complaints about Ruby memory usage, but I think it's in part because a large part of the community using things like Heroku with like 500 megs or something like that. So they can only have like 2-3 Puma workers. But at Shopify, like we run something like 32 unicorn workers, or one of our app is even like 90 children. Because as I said, like you have like 1 gig, and then if you have 10 process, like it's going to be 100 megs. So the more workers, Puma workers, unicorn workers, doesn't matter. The more you use of those, the less having some pre-computed memory in your application is a big deal, right? So you really want to benefit of that. And so yes, eager load namespace is a very underused API in my opinion. And our list at Shopify is like, there's probably 50 entries in there. It's just kind of ridiculous.
One thing I want to call out in this article I was reading on the thread or not the thread, I didn't know that the garbage collection like locks up the GVL across threads.
Right. That's another dimension of using Pitchfork versus Puma or Unicorn, is that traditionally, like I think a lot of people have migrated to Puma for various reasons. Like it's a very good server. I don't want to seem like I'm dunking on it or whatever. I think for most people, it's gonna remain the best server for quite a while. But Puma started using Thread, and the community in general started using Thread. It's true as well for Sidekick and for many other popular runners. as a way to fit in those small Heroku boxes. I mean, I don't want to say like 500 megs is small. I know that there's probably some people who are gonna say that's gigantic already. But like I think threads became popular in the Ruby community in good part to reduce memory usage. But then they bring this problem of like you're sharing your memory space, which means you share the global VM lock. So you're gonna lose, like if you have too many threads, you're gonna like your latency is gonna suffer because you're gonna hit the GVL lock. I think you had a very good episode with Ivo and Joe a few months back, which explained this in great details. Mm-hmm. And the second thing is that, yes, the GC is also stop the world. It's going to stop all your threads. So if you have two requests and one is spewing a lot of garbage, like allocating a lot of objects that the garbage collector has to clean after it, the other request that is totally innocent but is end up being in the same process, it's going to be regularly stopped as well. So you can... what I like and why we kept deploying Unicorn for so long at Shopify, we still, like our main apps are still on Unicorn. And sometimes I get the question of like, why didn't you migrate to Pima? I thought like Unicorn was deprecated or abandoned or whatever. It's because like this isolation, like being able to say like, this endpoint is like really well optimized and it's going to be not being impacted by a less important endpoint, but maybe wasn't as optimized. And they won't impact each other. And it's a very good property for us. That's very important. And the other thing is, of course, resiliency is like if for some reason something is buggy, like, like the Chia PC bug I told you about previously of like, oh, the VM is locked up or whatever. With Unicorn, there's only one request per process. So you can just use Unicorn timeout, which basically kill the process. Like when I say kill, is like Unix sick kill kind of thing, and like there's no coming back from that, and for sure all resources, everything's gonna be cleared up. Whereas interrupting a request in Puma is a bit more tricky. Like if you try to kill the thread, maybe it was holding onto something, and you might leave like the process in a weird state. So I sleep better at night knowing that we can just we have a very hard timeout. And if something really funky is happening, it's just going to go away.
Yeah, it's so funny that timeouts are such a problem in Ruby.
Yeah, I don't think it's particular Ruby. It's just very hard because it's very hard to really compute, okay, what's the maximum amount of time this request is going to take, right? Because you can benchmark it, but like you will need to do every single network call you do, you will need to sum up all the timeouts of it. So if you have like a 1 second timeout to Redis and you do 10 Redis call, but then maybe your request is going to make 10 seconds, which is awfully long for a web request. I mean, it depends what you do, but for the most part, I would consider anything above 100 milliseconds to be a bit on the slow side. So, but of course, you're not going to put a timeout on one of your database to 10 milliseconds to accommodate that, right? You cannot lower the timeouts enough. So, and then you also have the problem of batch requests, right? It's very common, like especially in Shopify, when you have like an admin panel of some sort. If you say, I don't know, delete products or delete rows, generally you have like a batch function where you can delete 10 at once or 100 at once or 1,000 at once. And it's very easy. It's very hard from like a big application perspective to say, okay, I'm going to enforce that every single of my requests going to end up in this meantime, right? There's a good pattern, like it's kind of not really the subject of today, but there's a good pattern for that, which is the deadline patterns, which is instead of having a fixed timeout for every single of your calls, you have like an object, you have like you allocate 5 seconds for your request, and every time you do a call, you subtract from that deadline object. And so if you only have like 10 milliseconds remaining and you try to do a call, it says like, no, sorry, you blew your budget and we stop there, instead of waiting for the web server to say, oh, it's been too long, sorry.
Yeah, I think I've also heard that as short circuit. Is that different?
I think you might mean circuit breakers, which are that's slightly different. Mm-hmm. That's also a gem I worked on. You might have heard of Simian.
Oh yeah,
that's a slightly different thing. It's more. it's more about detecting errors. It's like if you do 5 calls to the database and they all failed, you just start to assume the database is done and you stop doing calls, you immediately fail. This is the main reason is to avoid like a failing call is fine. The problem is the timing of call, because if you have like a 1 second timer to your database and you do 5 calls, it's 5 seconds. You much rather say, okay, the database is dead for now. We fail in like 1 millisecond, right? So it's a way to propagate errors faster to avoid cascading failures.
So I had a question about Falcon and how Pitchfork maybe parallels in some ways, because I know Falcon is not forking by default, but it does have a forking option.
Yeah, I haven't looked too much into it, but I think in Ruby, you could think that Unicorn is a forking server and Puma is a threading server, but actually in Ruby, there's no reason not to fork, at least for splitting your load a bit and then use either thread or fibers. I haven't used Falcon much. I think it's the whole async like fiber APIs Samuel is working on is nice, but I think it's nice because it allows me to do things that before people would have reached to, say, Node.js or Go before, like some very IO intensive. And when I say IO intensive, I don't mean like 80% IO. I mean like 99.99% IO. I mean like something where, you subscribe to a Redis, like you listen to a Redis stream or something, and then you just forward that back to clients that are listening to WebSockets or something, like those kind of teeny proxy things. Historically, like 5 years ago, everybody was doing that in say, Node.js, and I really don't like Node.js. So I'm happy that like next time I need to do something like that, I can just do it in using those async thing. But all the issue I have with threads, which is like the shared memory, like the shared memory, the GVL, the GC, all these things, they're essentially the same with fibers. Fibers are basically like very lightweight threads. So you can only have one fiber executing at once. So the problem remains. It's just a way to have tons and tons of threads. And actually, they're very slightly worse than threads, because let's say you use Puma and you have like your 2 threads, and one of your developer for some reason did a Fibonacci endpoint. You compute Fibonacci and like is asking for Fibonacci 50. So for Ruby, that's probably going to take 30 or 50 seconds to compute, right? And that's just going to be the CPU crunching up, and it's not even going to do any IOs. It's just going to crunch up. Well, with Puma, the Ruby VM is going to say, after 100 milliseconds, going to say, okay, this thread has used too much CPU. I'm going to let the other thread run for a bit. And like every once in a while, it's going to let it continue, but it's just going to prevent it from using all the CPU in the process and starving other requests or other collocated things. If you do this with fibers and Falcon, it's just going to compute its Fibonacci for 50 seconds and no other request is going to go through in that meantime. So, because fibers are not preemptive, except like what Samuel has been working on is like to make them automatically preemptive when they do IOs. But if you don't do any IO, you're just going to keep running. And so for me, I think they're great, but to do like some very tight systems where you don't use too much dependencies, you really know what you're doing, like those teeny services. But yeah, I would be scared to. I mean, we're an extreme case at Shopify, but like there's like literally hundreds of people committing to our monolith on a regular basis, and like some bad code goes through sometimes. Like having a system that's resilient to mistakes, but you just like, okay, a mistake went through and we can correct it later. It's very important for us. So like, yeah, that wouldn't work. I know there's a lot of people asking to make Rails compatible with Falcon. I did a bit of work in that regard, because I think some people out there certainly have the use case, but I think it's a minority use case. But again, like what I said for Pitchfork, every app is different and going to see different benefit from different systems. So I don't want to to say that like don't use it. I would like people to be very aware of like the trade-off basically, because any good engineer should tell you that nothing is better. Like there's nothing better than something else. It's just all trade-off, right? You just always lose something when you gain something. There's no free lunch.
This makes a lot of sense to me. Why you would go the forking route now? Because at first I was definitely questioning it. Why continue the long, drawn-out process of, this It seemed like things were getting, more along the threaded approach, and then
absolutely
pulled back. And from a Rails perspective, having all of that stuff loaded up front and then optimizing the memory as it runs definitely makes a lot more sense, because the average use case is what you have a database, you have Redis, and then that's it, and you're serving requests, and that's like a typical Rails app cycle. And then you have other services kind of built up, but for the most part, you have your primary bulk monolith stuff up, and then it just optimizes itself as it stays up. And so it makes a lot of sense now, seeing kind of where Shopify is heading with their copy on write optimizations and YJIT and stuff, to help support forking as like the happy path, the Rails way. I guess that makes a lot of sense.
Well, I don't have the pretension to say that it should become the happy path, but at least that it should be one of the supported paths. I just, again,
sure. I mean, like you're saying, every app is unique.
Exactly.
But
every app is a snowflake.
Every app is a snowflake. But I mean, in my experience, I've consulted a lot, and a lot of Rails apps are very typical and follow that optimizations that would be brought from a forking server. So it makes a lot of sense. But I'm curious to see what your thoughts are on how to juggle those two, and where Shopify sees this up. Because I imagine like Shopify has other things other than its monolith, probably hundreds of apps, maybe thousands.
Absolutely.
That maybe wouldn't work well also with Pitchfork or a forking approach. How do you juggle those two and help keep people on the right path?
So I mean, the way we approach things is that the company is too big. There's just way too many apps and way too many developers to be like to hold everyone by the end and do everything, right? So we try to work as like we write what we want is to write shiny tools so that you reach to those because they look cool rather than to do your own thing on your own. And that's how we help with standardization. If we really have to, we're gonna use like COPS or whatever, or like mandatory kind of proceedings. But ideally, I mean, at least the way I see it is like I like to, as you said before, create a happy path for people to go into rather than to try to police them afterwards. And so to give you an idea on the current situation is that like all bigger apps like the monolith and like the storefront render, like the one seeing a lot of traffic and that are under a lot of scrutiny, we definitely use Unicorn for them. And then for the long tail of smaller apps, especially like the internal ones and stuff like that, Puma is more the default right now. I don't think, like depending on all my effort to try to make Pitchfork really more plug and play, more easy to use by like making most of the ecosystem compatible with reforking, we might switch to it as a default later on, but like Puma is definitely gonna stay as like a staple for quite a while. And also the memory pressure is more and more a problem as the apps get bigger, right? As I said, we use, so for on our monolith, we use 32, like we fork 32 times, like we use 32 workers for web server on the monolith because we need to really shrink the memory usage. But we have some internal apps that don't even need 32 workers to save the amount of traffic they get. So there's also the question of like, at which point does Pitchfork or things like that will become an interesting memory optimization and like a cost reduction for Europe. Because I was saying we have a gigantic monolith, but then we have a long tail of like probably 1,000. I'm not even sure of the number, to be honest, but like 1,000 Rails app left and right. Some are internal, some are like applications that you can install on your Shopify platform. So they're developed like as a add-on kind of thing. Like there's really a lot of different applications, and they're all Rails.
I found the project on GitHub under Shopify/Pitchfork, so you all can find it there. And yeah, let's go ahead and just move on to the next segment of the show then, and do our self-promo shout-outs. So Valentino, we'll start with you. What are you working on that people should know about?
Let's see. Right now, I'm continuing to work on my it's an AI project at Doximity called Docs GPT. Really excited to release it officially. It's out now. You can play with it. But basically, just putting some of these Chat GPT tools in the hands of doctors in the context of healthcare. So we're doing a lot of fun stuff. And I've just been having so much fun playing with the AI. It's too fun, you know.
Very cool. That does sound like fun. I think I mentioned this last week, but I'm still working on getting the launch of the Catapult Your Coding Career podcast up. I'm hoping to get it to the point where it's a daily podcast, probably 5 to 10 minutes. And I've been doing coaching with people. I've just had people coming in and, we kind of do a preliminary coaching call. Some of them sign up for actual coaching, but a lot of them are asking the same kinds of things. And the other thing is that I went through a process when I was a newer developer, just learning new things and advancing and, having a mentor and stuff like that. And so I wanted to share kind of the things that I learned that worked for me to level up in the ways that really mattered so that I could get the job that I wanted. And so just walking through that. And then, from there, once you're a senior developer, architect, whatever, people have all kinds of names for the positions, right? Then what? Then how do I go from there to making a difference in the community and contributing and, creating content? And so I'm planning on covering the whole process to that. I'm planning on talking through a lot of the issues and answering the questions. So you can check that out at catapultyourcodingcareer.com, or you can just find it on topenddevs.com. Jean, what are you working on that people should know about?
Well, I was saying earlier, I'm like working on onboarding some apps to Pitchfork, but at the same time, I'm also working on like tuning the garbage collector settings in our monolith, like this week, because we recently upgraded to Ruby 3.2, and there was some kind of major change, so we need to redo our tuning, and like we're trying to just really reduce the latency impact of GC. And we're discovering some nice stuff. So we're probably gonna take a while, but we're hoping to come up with a blog post with a guide on how to tune GC. Even though the first line of the guide is gonna be, you probably don't need to do it, but
yeah, but it's something else to tinker with.
Yeah, but you can do some interesting things. You can instruct the GC that like, I'm definitely gonna need that many objects at runtime, so just don't bother. Start directly with that much space available. You can also, you have a bunch of like the GC use heuristics. Basically, it just tracks a bunch of metrics and say, when I cross this threshold, I'm just gonna do a major GC. I'm gonna go over all the heap, right? And that on big heaps, that can take like a long time. And we just found like our GC was way off on some assumptions, and we'll probably have some nice things to share it's gonna take a teeny while before we actually write the post, but like a good month or something.
Cool.
But yeah, you can also shoot yourself in the foot by like setting the limit too low or something. Like some developers at Shopify have been trying to optimize the service by just trying to do what I don't know if you remember back in the day, people were doing out of bound GC. Like it was this idea of you don't disable, but like after the request is complete, you run GC to just try to make space so that hopefully you don't actually trigger GC while you perform the request. But the idea is just you raise the limits basically, and then you explicitly trigger the GC at certain points. But by doing so, like they actually made things worse. Like they called us to say, oh, we have problem with the GC. And the first step we did was just like, oh, we're going to reset to the default config. And it just immediately went way faster. So that's why I really want to warn people out there, like just don't do it unless you're set and you need it.
All right. Well, let's do our regular picks. Valentino, do you got some picks?
Sure. So thanks to Jean's GVL instrumentation API, I know I've always given this recommendation before, but he has a GVL tracing gem now. You can trace GVL stats. Pretty great stuff. Yeah, I see you also have contributed to that, Jean. So thank you. I'm poking around in there too, trying to see what's happening, because it's definitely interesting that now that I know that threads lock like that during garbage collection. It's just interesting to see what's happening under hood. The other pick I have is it's called Watch Me Forever. And one of my coworkers shared this, and it's basically an AI generated sitcom cartoon that mimics Seinfeld, and it's just continuously new content that is all generated live, so you could just go and watch it, and it's a new episode of Seinfeld recreated as like this weird like it's really kind of amusing to watch, and kind of just incredible. So I recommend checking that out as well.
Awesome. All right. I'm going to throw in a few picks. So this week I'm going to pick what was it that I picked? Because I always start with a board game, and my brain is I picked Sushi Go Party. So Sushi Go Party is a game you play. You can play 2 to 8 players, and it tells you how to kind of build the deck up, because you have different food items that you add into it, kind of like from a sushi restaurant. And then they each score differently, right? So some of them are worth just straight up points. Some of them are worth, like 3 of them are worth 10 points, or 2 of them are worth 7 points, or like there's the spoon that allows you to basically put a placeholder down, and then when you use the spoon, what you wind up doing is you put 2 cards down and you put the spoon back in your hand. But when you play a card, and then you pass your hand to the left. And so you're consistently having to choose, trade-offs, because somebody may take the other card you want before the hand gets back to you. It's pretty simple. Board Game Geek ranks it at a 1.3 weight, so it's a pretty easy game. But it's a lot of fun. And my sister and brother-in-law, when they come over to play games, a lot of times if we have just a half hour before they're going to take off, that's what they do. They just, we'll just play that, and then they'll go. So anyway, it's a fun game. I really like it, so I'm going to pick it. As far as other picks go, I'm going to pick Riverside. That's what we're using to record this. Like I said, I'm starting new podcasts, and Riverside's awesome. Even if it's just me by myself, since it records a local version for every person. If their bandwidth isn't good or something like that, it compensates for all that stuff, because you still get a local recording. But the other thing is that it makes it really easy for my team to pick it up, because they can pull the recording off of Riverside, basically pull it out of the cloud. My editor can do his thing. You can actually, when we're recording, you can put you can mark a clip in here. And so we're going to start actually putting on social media like 30 second to 1 minute clips of us talking, right? So whatever the highlights are. Anyway, it's going to be awesome. So we're really getting into that and making that work. And then one of the other things that they're going to do with those videos is we're going to open up a TikTok account. And it's going to be a mix. It's going to be a mix of clips from the show and of me basically sharing some of the stuff from either Catapult Your Coding Career, or I may just get on and say, hey, here's what I'm doing in my office or whatever. And you'll be able to see that on TikTok and Instagram. So if you want to follow us there, it's Top End Devs in both places. And yeah, anyway, it's been real fun to just kind of play with some of those tools and see what you can do. And then the last pick I'm going to pick is Midjourney AI. I've been using it to generate artwork for various things. I've actually used it. It's a lot cheaper than having 99 Designs do a podcast artwork design. If I can get a picture I like and put the podcast name on it, I am totally good with doing that, right? As long as it reflects what the show's about. I do kind of like the logo approach of like the Ruby Rogues podcast artwork, right? It looks more like a logo and less like a AI generated picture. But sometimes when I tell it to generate like a logo or logo artwork, it puts like weird, because it's generated off of other content, right? Is the way that it works. They've got images that have been put in, and then it ingested it into their AI algorithm. And so when you ask for something, it uses the keywords for those other things. And so you get weird text artifacts in it. And I don't know that I necessarily know or want to know how to go in and clean those up. So anyway, it's also nice because I've been putting the artwork in on emails and stuff like that on the email list. And so it's been nice to kind of have something that I know isn't copyrighted, right? That I can stick in. So unless it's, got blatant something that it pulled off of somewhere that is copyrighted, it's good to go. So yeah, so I'm going to pick Midjourney AI, and I think that's what I've got. Jean, what are your picks?
Well, it's not going to be very original, but I'm going to pick a Ruby 3.2 because it just got out of there not so long ago, and I think we've seen an increase of people upgrading fairly early. I've seen a bit of chatter about it on like Twitter, Reddit, or whatever, but I really want to recommend upgrading. It just performs very well. It's quite stable. There's a few teeny YG corner case bugs, but like we should have 3.2.1 in a matter of days or week now, because very soon. And there's some nice things like Valentino said, there's a GVL API I implemented, which allow you to instrument and to know whether you're using too many threads or not. There's YGIT, obviously. I work closely with the YGIT team, and I know they're dying for more, not necessarily public chatter, but like more public feedback about like, did it work well on your application or not?
Right.
Things like that. So yeah, that's what I said to Matt a while ago. There was this public common knowledge in the Ruby community of like the pointer releases were RCs at best, and that you should wait for like the 0.1 or 0.2. But this has changed, and there's no problem putting a 3.2.0 in production. So people, if you hear me, please do. You're missing out.
Yeah, I've been putting anything new that I build on 3.2, and it's cool. I like it. All right. Well, we're going to go ahead and wrap up here. Thanks for coming, Jean. Until next time, folks, Max out.